So when we're studying psychology, it's important to remember that psychology is a science, and the thing that makes it a science is the fact that it uses the scientific process and it uses scientific methods in order to establish theories which are based on evidence and research. So this is fundamental to the study of psychology. I'm going to keep coming back to it throughout the course, and we're going to look at a lot of different research methods that you need to know in order to fully understand where the psychological theories have come from and in order to be able to evaluate them effectively. So the scientific process then, this is a cyclic process in which generally we're asking questions, we're looking for evidence, we're testing hypotheses, and then we're developing theories based on the back of that data that we've collected. So to take an example then, we're going to start at the very top of our cycle with number one, making observations. So you might notice something about the world around you that makes you start thinking about things. So for example, you might observe that people tend to like ice cream. Ice cream is a very popular food, particularly with children. So you might start thinking of questions around this, and you might ask the question, well, is this something we're born with? Is a preference for sugary or fatty foods innate, or do we learn this? Now, once we've asked that question, we can start formulating hypotheses. Now, hypotheses is a testable prediction about a particular thing. And you might formulate more of a general one to start with, but when you actually pick your research, when you actually start to go into doing your study, your hypothesis needs to be very, very specific. So in this example, I might write the hypothesis that infants will choose full-fat ice cream more often than low-fat ice cream. So it's very specific to my study. It's what I think is going to happen in the study that I carry out. So once I've got my hypothesis, I then have to choose how I'm going to collect my data. There are lots and lots of different ways that psychologists use to collect data. Observations, experiments, self-report techniques, which is when you use interviews or questionnaires or case studies. Whichever way you choose to collect your data, which will depend on what you're doing, you need to make sure that once you've done that, you can analyse your data for trends, for patterns, and then you'll either accept your hypothesis, you'll reject it, you'll change it slightly, you might expand it, and you might test it again. So this is where the cycle comes in. You gather some data, you make amendments to your theories or your ideas, and then you test it again, and you'll keep doing that. Once you've got data which you think you can develop theories from, you'll come up with some sort of generalized theory that explains why you've got the evidence that you have. So in this case, I might say that sugary or fatty foods was adaptive for us in previous generations, so it enabled us to survive. Therefore, we're more likely to eat sugary, fatty foods today because those genes have been passed on. Now, when we're looking at the scientific process, it's really, really important that we remember that we adapt our theories to suit the evidence. We do not look for particular evidence to suit our theories, and we certainly don't adapt evidence to suit theories that we want to be correct. So we start with the evidence as our base of knowledge, and then we create theories that fit that. Now, within psychology, we are going to look at all of these different ways of collecting data, so observations, experiments, self-report techniques, etc. The one we're going to focus on today is experiments. So when you say the word experiment to people, what they often think of is something like this. So maybe something in a lab where you're adding chemicals together. That doesn't make an experiment. So an experiment is defined by changing one thing or manipulating an independent variable to see how it affects something else, which is known as the dependent variable. So within this situation, we keep everything else the same, so everything else is controlled. And if we manage to keep everything else controlled, then any change we see in the dependent variable must be due to the independent variable. And because of this, we can establish cause and effect. Now, the reason experiments are so powerful is because they are the only research method where you can determine that one thing has caused another thing to happen. Other research methods may tell you that there's an association between those things, but actual cause and effect requires you to manipulate an independent variable to see the effect on the dependent variable while keeping everything else controlled. Now, there's a lot of vocabulary to do with experiments and investigations. Some of this you will already know. Some of these terms might be new to you. So, starting off very simply, an aim is the purpose of the study. Hypothesis, I mentioned before, this is a testable statement about what is going to happen in the study, and it's very specific to the study that you are carrying out. We'll come back to hypotheses a little bit later in this video. A variable is, as the name suggests, anything that could change, and there are different types of variables. So 4 types that you do need to know. Independent variable, we've said, is the thing that you change, the researcher manipulates, and a dependent variable is the thing that the researcher is measuring. Now, an extraneous variable is something which the researcher needs to control. So this is something which the researcher will have noticed in advance, and they will take steps wherever possible to make sure that doesn't change between the 2 conditions. Sometimes this isn't possible, and that's where you would end up with a confounding variable. So a confounding variable is anything other than the independent variable that did affect the results. So if we think of the situation where you're changing the independent variable to see the effect on the dependent variable, if you can't keep everything else the same in that situation, it could be the independent variable, or it could have been this other thing that caused the change, which is why that control over extraneous variables is so very important in experiments. Other vocabulary you need to know: operationalization of variables. So this always trips people up, but really it's just about making the independent variable and dependent variable testable. So we're talking about units of measurement. If we go back to my example, talking about ice cream and whether the desire for fatty and sugary foods is innate, I operationalised that by saying I was going to count the number of times an infant chose low-fat ice cream and the number of times that they chose full-fat ice cream. That is my operationalisation. That is how I was going to measure it, how I made that testable. The control group, this is the group of participants for which the IV isn't going to change. They're the baseline condition. And the experimental group is the group of participants for which the independent variable does change. So you're going to compare the results of one group against the results of the other group to see whether there's been a change in the dependent variable. The control condition is the task or the situation which the control group undergoes, and the experimental condition is the task or situation which the experimental group undergoes. Now, some of this, because a lot of these terms sound familiar, it can get quite complicated when you come across these words for the first time. It's important that when you're thinking about investigations or studies, or you're talking about them or you're writing about them, you try and use these terms as correctly as possible. The more you use them, the more familiar you'll be with them, and the easier they will become to use just within your general language. So when we're thinking about using these terms, some of them are terms which are perfectly valid to use for any type of investigation. If we think of the word investigation as being an umbrella term for lots of different research methods, so all of these words around the edge you could use if you were talking about experiments or observations or most other type of research method. There are certain ones, though, which you would only talk about when you're thinking about experiments. So these are the ones in the middle. You cannot use these if you're talking about questionnaires, for example. You can't talk about an independent variable or a control group or anything like that. So hypotheses then. There are 2 different types of hypotheses that you need to know. So we said that a hypothesis was a testable statement about what would happen in your particular study, and you can either have a directional or a non-directional hypothesis. So a directional hypothesis, first of all, is one which tells you that there will be a difference between, for example, the control group and the experimental group, and it tells you what that difference will be. So in this example, people will help people who are similar to them on more occasions than they will help people who are dissimilar from them. A non-directional hypothesis, by comparison, tells you that there will be a difference, but doesn't tell you which direction that difference will be in. So, for example, people will help people who are similar to them on a different number of occasions than they will help people who are dissimilar from them. So if we look at the difference, or the key difference between these 2 statements, in the directional hypothesis, you're actually saying that people will help others who are similar to them more than. So it could say less than. You're saying there will be a difference, and I'm saying you're going to help people more if you are similar to them. In the non-directional hypothesis, you're saying there will be a difference, so people will help people who are similar to them on a different number of occasions, but you're not saying whether that number will be greater or less than they will help people who are dissimilar from them. So depending on how much prior knowledge you have on the subject, depending on how much research has been done on that subject in the past, will depend on whether you choose to have a directional or a non-directional hypothesis for your study. So you can have a look at the pre-reading for more information on the scientific process and experiments. And before you come into the lesson, make sure that you can explain the scientific process as a cycle which investigates new knowledge and confirms existing knowledge. Explain what we mean by an experiment and define the key terms associated with it, and explain the difference between a directional and a non-directional hypothesis.